Hi there! This video series is to display my problem-solving and learning abilities. I plan to show that I can solve any programming problem, regardless of whether I already have expertise in a particular language. I hope this helps others in my field to learn not just how to solve a particular problem, but how to teach themselves a solution to an unfamiliar problem. Currently, I am learning Python. I have no professional experience in the language and have only been learning it since mid-January. My only formal training is completing the Python for Programmers course on Execute Program. While I'm picking Python up fairly quickly, I cannot claim any real expertise. Today, I'm showing my approach to solving the 19th Project Euler problem from start to finish, vocalizing my thought process throughout. As always, I will link to both Project Euler and my repository in the description. Let's dive in. Problem 19, Counting Sundays. You are given the following information, but you may prefer to do some research for yourself. 1 Jan 1900 was a Monday. 30 days has September, April, June, and November. All the rest have 31, saving February alone, which has 28 rain or shine, and on leap years 29. That is a very long version of that poem. A leap year occurs on any year evenly divisible by 4, but not on a century unless it is divisible by 100. Or 400. Ha! How many Sundays fell on the first of the month during the 20th century, starting from 1 Jan 1901 to 31 December 2000? So, let's see. I think that an appropriate starting point is to look this date up and see what day of the week it was. January 1, 1901 was a Tuesday, which, of course, makes sense because 1900 was not a leap year. Not evenly divisible by 400. 2000 was a leap year, though. So, for this exact problem, we don't have to worry about this not on a century apart. So, I'm going to ignore it. Every year divisible by 4 for this exact range is a leap year. So, Python, oldest date. So a thing about programming is that a lot of time the oldest time that can be represented is actually in the 70s, which is probably why this goes back as far as it does. For instance, like in Java, if you could go back to 1 Jan 1901, you just continue to add 7 days. That's how many Sundays there are. We're probably going to have to do something like that, but instead of using a library, it's probably going to be more, manual. Maybe we should make it more manual anyway. Okay, you cannot reliably process dates before February 12, 1582, which you may recognize is, much before 1901. Okay, so let's click that link about the Python library datetime, which you might remember if you've seen my previous videos. I've been using on most of these to make sure I know exactly how long my program takes to run. So, actually, maybe it makes sense to start there and just kind of do an experiment. So the number of Sundays in any given year should be around 52. Hold on. Yeah, so it should be at least 52, sometimes 53. What if we do mod 7? Cool. So 52 weeks and 1 day in most years, 52 weeks and 2 days in leap years. So for 1901, if we try to do this and we don't get an answer that's like basically 52, we've done something wrong. And honestly, we could say for this time frame we're looking at exactly 100 years. The answer is going to be close to 52 times 100, which is 5,200, plus 100 divided by 7, which is 14. So our correct answer is going to be close to 5214. It might be 5215. But it's going to be very, very close to this. Actually, in a century, there's going to be about 25 leap days. So it's going to be like 5217 or something. 5217, 5218, somewhere similar to that. But for right now, let's just kind of look at this. We know about this datetime library. I feel like maybe using the datetime library is not what they want you to do here. But I believe very strongly that when you have a tool that does the job for you, you probably should use it. So let's go ahead and make our problem18.py. Or rather 19, because that's the problem we're actually working on. And again, do our little yoink. Copy the actual problem statement, because fun fact, my brain is very good with calendars. I already have all of those rules memorized, or at least close enough. And I believe the datetime library does include just the date part. So an idealized naive date, assuming the current Gregorian calendar always was and always will be in effect. So let's go ahead and Gregorian calendar adoption. Okay. Some states adopted it from 1582. A lot of people started using it because a lot of people were Catholic. And it was invented by Pope Gregory. Some countries did not change until the 19th or 20th century. So, which countries, I would like to know. So, Great Britain adopted it in 1752, when America didn't quite exist yet. Alaska remained on the Julian calendar until 1867. So it looks like if we take an American-centric point of view, we don't have to worry about the actual calendar changing. And that is what I am going to do for purposes of this. So here's what we're going to do is we're going to import date also. And let's see. Year, month, day. And obviously we want to start on January 1, 1901. Month is not zero indexed, which is great, because in some calendar types, in some programming languages, month is zero indexed and nothing else is, and it gets real confusing. So yeah. So if we do our cur date equals date 1901 for the year 1-1. Okay. And then, since that is a Tuesday, actually, does this library give us the day of the week? Let's see. Excuse me. I think most likely... Aha! Weekday. So... date, time, and what we want to be able to do is actually add days. And I'm not certain we can. I know this is a thing in other languages. Okay. So it looks like we can get our date, and then we can use time delta days equals. So we also want to import time delta. And then what we're going to do is while cur date dot ISO weekday, maybe? Just weekday. While not equal to 6. Cur date equals cur date plus time delta days equal 1. So what I think this is going to do is give us the first Sunday. And then we can have num Sundays. Okay, so that's actually pretty bad. That is not following any convention. Just it's habit to capitalize Sunday, isn't it? Num Sundays equals 1, because current date is the first Sunday. And then while... let's just do last date equals date 2000. That's a 1. 2012 31. And then while cur date is less than last date, and I'm choosing less than, not less than or equal to, because if it so happens that the 31st of December 2000 was a Sunday, I want to count that day. And then we're gonna print the number of Sundays. Cur date less than last date. Actually, num Sundays equals 0. And what I'm going to do is num Sundays plus equal to 1, and cur date equals to cur date plus time delta days equal to 7. Now, if this doesn't give me a number that's somewhat close to like 5218, 5217, 5218, I'm going to assume I did this wrong. But let's see what number it does give us. And how long it takes. Okay, so obviously doesn't work. Date value out of range. Okay, so it seems like this is interesting, right? I'm just gonna do a print here. So print, use our little f, and I'm actually gonna do cur date dot string from time, and just do year, month, day. We don't need more than that. Okay, so bad. Obviously, very bad. Let's do that again, but stop it almost immediately. As close as possible to almost immediately. Whew. Okay, so obviously this cur date dot weekly isn't working. With weekday of cur date dot weekday. Let's see how that works out again. Aha! can't compare the method to an integer. Gotta actually call the method. Okay, we did it. And it looks like that is correct. Look at that. That's the 5217, which is what I said it should be close to, just based on the maths. But let's see whether that's the actual correct answer. I have a feeling it might not be. Let's see. Nope. And my guess is that it's actually 5218. But let's instead of using these fancy libraries, let's try to do this manually, huh? I still want to use date time for, you know, our own purposes. But we know that the first Sunday of 1901 was January 6th. Which actually doesn't make sense. So wait. No, yeah, it does, because Tuesday, Wednesday, Thursday, Friday, Saturday, next day would be Sunday. So our first Sunday is January 6th. So start date, I'm going to do a dictionary of my own design. And it is going to be year 1901, month. Actually, let's just say this is cur date. Month of 1 day. And I'm going to start with January 6th. Not very much point doing otherwise. I'm going to also create a dictionary called month lengths. And here I'm going to do 131 to I'm just gonna put 28. Or actually, find days in Feb. And we're going to take in a year. And basically what we're going to do is if year mod 4 equals 0, return 29, else return 28. Again, we are ignoring that rule about only centuries that are evenly divided by 400 have the leap year, because 2000 is evenly divisible by 400 was a leap year. So then March also has 31 days. Yep. 4 is April, which only has 30 days. 5 is May, which has 31. 6, June has 30. July has 31. August has 31. September has 30. October has 31. November has 30. 12 has 31. And let's double check ourselves right there. So September, April, June, and November have 30. September, April, June, November. We got it. Okay, so here's what we're going to do. Let's set our num Sundays again to 1. And what I'm going to do is say while cur date year is less than 2001. Cur date equals add week cur date. Actually, set that again to 0 so that we can just do num Sundays plus equals 1 here without having to worry about our count being off. And obviously, I called a method that doesn't exist because I haven't written it yet. Okay, so let's see. So max days equals month lengths okay, yeah, no, we can do this. Max days for this month is going to be if date month is equal to 2, then we're going to do find days in Feb for date year, else it's just going to be month lengths for day month. And I think that this month lengths is going to have to come up. Okay, so I think I just did this incorrectly. I wrote it as if it would be in Java again. Okay, so I think that's how a ternary is done in Python. I guess we'll find out whether I am right. New day equals date day plus 7 if new day is greater than our max days. Then we're going to have to increase, let's just throw a comment in here, increase the month if month changes to Jan, increase the year. So let's go ahead and define this a little bit differently. So I'm going to go ahead and define new year is equal to date year, new month is equal to date month, new day is going to be day plus 7. So if new day is greater than max days, new month is going to equal... Well, really, it's just going to plus equal 1. Why not just use that? And then if new month is greater than 12, now it should only ever increase to 13, so it should never be more than that, because we're only added 7 days. If new month is greater than 12, then new month has to be set back to 1, and new year, wrong variable, is going to plus equal to 1. And then either way, new day is going to equal to new day minus max days. So let's think about this for a second. Let's say it is January 30th. We add 7 to that, we get 37. The 37th of January is the 6th of February, because 37 minus 31 is 6. So that should work just fine. And then we want to return just this new dictionary of year as new year, month, new month, and of course day, new day. Now, we are making some assumptions here about, like, adding this week. Let's see if this is going to turn out to be the 5217 again. That time we got 5218. So, I wonder what is different there. I bet you it didn't count, like, one of the leap years or something. Let's see if 5218 is the correct answer. I think it most likely is. Oh, so no, it is not. At this point, we could just keep going up a little bit, but... let's see. Leap years 1901 to 2001. Cool. So let's see if there's any in here that we would not expect. So 1901 is not one. 1904, 8, 12, 16, 20, 24. Keep going up by 4. Yeah. So that seems like what our algorithm should have told us. Um... So this is about, like, whether we... Most of these links appear to be about whether we, count our centuries with year 0 or year 1. Okay. So... I really don't want to accept and download some random thing. Feels like this isn't quite right. Yeah, calendar not mentioned in that article. Was the year 2000 not a leap year? No, it was. We saw it in that list just now. Okay. So, I'm kind of under the assumption that maybe something is different here because it says you may prefer to do some research for yourself. Oh. Well, maybe if I had read the entire question. So I'm just counting how many Sundays there were. And it's asking how many Sundays fell on the first of the month. That's going to be a very different number, you know? Okay, so, new idea. We're just going to say if occur date, day, we don't need these parentheses, I keep doing this, equals 1. Then num Sundays plus equals 1. Now, let's see. That number I would expect to go down significantly. It's going to be at most a quarter of itself, probably much less. Okay, now we get the number 171, which seems much more legitimate. Let's see what it says for that one. That's the correct answer. So, lesson learned here is read the actual problem. Solve for the problem in front of you, not for what you think it is. And when it seems like you're not getting the correct answer, double check the problem. So yeah, obviously I was just counting how many Sundays there were for this century. Trivial problem I already kind of showed. How many Sundays fell on the first of the month? Different question. But it looks like we did get the correct answer. I'm pretty solid about this algorithm. I think that is pretty good. Not sure if we could get the correct answer using the Python date library, especially considering we got two different answers when we were just counting the Sundays. I have a feeling that not all leap years are in that library, or maybe leap years aren't all accounted for some. But either way, we did it. And this probably went through a few more iterations than it needed to, just because we were still adding a week for that last December, and at that point we could have known, like, no, we're not gonna get a new we're not gonna get a new one. But I'd rather have, like, was it 3 or 4 more implementations of the loop than necessary than to get the wrong answer. And again, Python's very, very quick, so even having it do that small number of loops wouldn't make a difference in almost any programming language. But yeah, could we have done this more smoothly? Probably. But this will work, and I think that it is very... almost the best way to do it if we're doing it manually. Again, I would rather rely on libraries someone else has written than write my own. In almost all cases, it just seemed like the library wasn't going to give us the correct number. So yeah. There we go. Problem solved. Let's see, so I feel like I went through this a little bit quickly, perhaps, but I'm basically just saying if we have calculated that our next day to analyze is going to be, like, outside of this month, we change the month. If on changing the month we've gone past December, we go back to January and increase the year as well. Anything else in here that is maybe a little bit tricky? I want to emphasize again that this will not work for every century year. Works for the year 2000 because the year 2000 happens to be divisible by 400. Will not work for the year, like, 1900, I don't think. Yeah, because any year divisible by 100 is also divisible by 4, because 100 is divisible by 4. 1900, not a leap year. But this would give, this little method here would give the wrong answer for the year 1900. Again, not worried about that. Not part of the problem at hand. Sometimes it's best to ignore things that you don't need to account for. In fact, that's one of the principles of clean code. But yeah, so we're looking good here. We got the correct answer once I went back and checked that I was asking the correct question. So yeah, I'll call it there, and I'll see you in the next one.